Now, whether you're a DC or a DCC modeler, there are always options available for automation. So let's take a look at some of them. Hi, welcome back to Chadwick Model Railway. I'm Charlie. I feel a lot of people shy away from automation because of a perceived complexity, but it doesn't really have to be that way. But then why would you want any automation in the first place? Well, you might have a layout where you like to do a lot of shunting, but you want your trains running at the same time. So you could easily have a DMU perhaps in the background running from one end of your layout to the other, while you get on with something that perhaps might be more interesting, like shunting up some wagons or building up some coaches. Or of course you could do something else, nothing to do with the running of your trains. You could be just sitting there happily in your little railway room painting figures whilst your trains go trundling around in their small shuttle sequences. Automation can go from the very basic to the hugely complex, such as down at McKinley, and there should be a link here to that beautiful monster layout being built by David Townend. So what do you need to get some kind of automation into your layout? Well, it depends on a couple of factors really. It depends on, firstly, your enthusiasm, your skills, your budget, and of course your time. And all these factors put together might lead you in one direction or another. So what I'd like to look at first is a basic DC shuttle. Now I must thank Callum Wilcox from SDJR7F88, who has his own channel. And here you can see Callum's lovely little Christmas layout. It's a micro layout, and you can see the tools that he's used. Now the hardware in question is from Block Signalling, and it's an SS2A DC shuttle with acceleration. It's quite a basic package. There's a couple of diodes that you can see at the top, and then a circuit board. Towards the bottom right of the circuit board, there's a black boss there, and that's your input for your 12 volts DC. And just above it, there's a terminal block which takes track power off to the track. Over on the left-hand side, marked speed and time, there are two potentiometers, and those are adjustable to adjust the speed of the loco and the time that the loco will dwell at either end of the shuttle. You do need to cut the track in two places at the either ends of the shuttle. So Callum here has used a pair of Zuron track cutters to cut through, and then with that gap you then need to bridge it with one of the diodes. And here you can see where Callum has soldered it across the gap onto the rails. Again, repeated at the other end. Diodes are polarity conscious, so you have to make sure you put the diode the correct way around, and here in the instructions it couldn't be more simple. And there's your 12 volts DC going in, and your red and black cables going out for track power. So when you commission it, all you need to do is adjust the potentiometers to give you the right effect. And here we can see his little 040 saddle tank loco trundling to and fro on his Christmas micro layout. And then once again I must thank Callum for allowing me to use this footage. But what it does show is what you can achieve with a small cost and minimum technical know-how. Now with DC shuttles we can in fact take it a stage further. Oh, and thank you very much, Simon. Now there's another automatic shuttle from Block Signalling, and it's their PTS1 automatic DC shuttle with points control. This is quite interesting. Similar to the last one, you have one railway line, except this time you can have 2 points which can actually control 3 trains. So you can have train 1, train 2 and train 3, and if you wanted to send train 1 over into this empty siding, it would, and it would stop on arrival. Then Train 3 might go over to train 1 siding, and train 2 might go across into train 3 sidings. All straightforward stuff, except this time the module changes the points once a train has arrived, and it just leads to more interesting shuttles. Again, there's a diode that's inserted into the track to let the controller know when the train's arrived, and you can set the speed of the train going through and of course the duration before the next train starts up. However, before you leap away and buy one of these, the instruction manual is 17 pages long, and you do need some kind of technical know-how. It's not just as simple as the one that Callum Wilcox has shown, and it's not as complicated as something like block detection, but you do need a basic sort of electrical understanding. Now, Ian, who lives down the road, good friend of mine, you may have seen him in the Chuckle Brothers video, he has a DCC layout, and with this arrangement running in the background, it's just that he only has it with one point at one end, and so his trains then cross into behind the back scene, then into the layout, pull up at the station, pause and turn around and go back. So let's have a little look at his layout. Then when's the loco going to go?
Now.
And thanks again to Ian for allowing me into his railway room to record such ropey mobile phone footage. Well, things are obviously getting serious because I'm using my notes. And as we move into computer control, there are really only two sorts of systems now. There is either a time-based system or an occupancy type system. And the time-based ones I'm sure you've heard of are the Hornby E-Link, the Dynamis Ultima, Marklin and ECOS systems, and these tend to be based on time. With block detection, however, there are sort of two systems of detection really. There's current consumption or a momentary sensor such as a reed switch or an infrared switch. So you're not just stuck on one, there are various options available. Obviously you need a computer. Now I use a wretched old Toshiba computer that I think was built around about 12 years ago, and with Train Controller Silver it seems to work fine. Yes, it's nice to have an upmarket machine, but the point I'm trying to emphasize here is that you don't necessarily need the latest and greatest, because these are not really RAM consuming products. I mean, well, I certainly know that Train Controller isn't. It seems to be quite stable on an older machine. And in some ways, you know, older machines may well be more stable. So you need a computer, and then you need a computer program. Well, there are quite a few around. I use Train Controller Silver. There's Train Controller Bronze, Silver or Gold, and you pay for them, and you pay quite a lot for them. And obviously the Gold is far more expensive than the Bronze kind of thing, so I've taken the middle ground. There's also a program that's becoming more and more popular now called iTrain, and again you pay for it, but it appears to be the new kid on the block, and it is certainly worth investigating before you part with hard cash. There's JMRI, which is a free open source program which can take some work, but then if you're so technically minded, then it may well work for you. And then there's the old favourite of rock rail. Digitrax have trademarked a system known as LocoNet, and other companies that use the LocoNet system within theirs. So you may find that certain components between systems are compatible. The DigiKeys uses LocoNet, as does Digitrax, and you might find crossover with components, but again, buy with care. So where do you go from there? Well, if you're going to go into computer control with current detection, then clearly you're going to need sensors based around your layout that will detect when a train moves into a block. So you have to isolate certain aspects of your track from each other. So I'm a black to the back kind of wirer, so all my front rails are red and the black ones are back. I never chop up the back rails, I always chop up the red ones. So moving into a station, you might decide to have a large station block, and as that train draws into the block, you can tell the train to slow down and stop. And if the train has the correct profile, it will do so, and quite accurately. People think that a sensor such as a BDL168 will run a block. Well, that's not necessarily true, because one block may well need more than one sensor, because as the train comes to the end of a block, it may drift a little bit further or a little bit shorter, because the engine may not have warmed up yet, or it may be warmed up and it will run longer. So there is a bit of variation. So if you put a sensor at the end of the block telling it to stop, if it hasn't stopped, it will stop then. And it's a good way of looking at it. But when you come to save money, scrimping on the amount of detectors isn't the way to go. You really need to plan the layout through before you spend hard cash. And we are talking hundreds and hundreds of pounds now. I mean, a BDL168 retails, I think, is about 140 quid. The DigiKeys equivalent is about half the price. So before you do as I do and kneel at the altar of Digitrax, you do need to do your homework. Now, I have given a local electronics model railway company, which is DCC Train Automation, a plug in the past. And the reason I've done so is they have been very helpful to me. The guy who runs it, James, is a font of knowledge. He really is. He knows his stuff. He's not necessarily a model railway enthusiast as we would know one, but he is certainly a model railway electronics whiz. So if you buy from him, he does offer a form of, a technical advice after you've done so. So please make a note of him. His link is in the show more tab. But in-depth expertise in these fields isn't really that easy to get hold of. And naturally, I've gone to him with issues and he's sorted them out for me, and I'm extremely grateful. So let's take a look around my layout of how far I've got with the build, because when I lay track, I am laying it in sections with block detection in mind. So here's the main board, and as you can see, controls most of the electronics. If I switch my layout on, then the Digitrax systems flash up, and using LocoNet they communicate between each module, so that the command station at DCS240 knows exactly what's going on. It knows the points position, and it will know through the BDL168s which blocks are occupied. It looks more complicated than it really is, but if you'd wired it yourself, you'd know what I mean. Regarding the individual components, this is the PR3, which communicates with a computer. This is a BDL168, and these are the DS64s, which control the points. And really everything else is just duplicated. Now, I did say that this was an old computer, and as you can tell, it's running Vista. If I go into Train Controller, a few days ago I'd got to the stage of drawing the layout, and this is stage 1 of my build, and you can see the basic track plan. And if I change this point, hopefully you can hear the tortoise motor turning over. And the tortoise motor, as all of them, talk to their respective DS64's controllers, and then via LocoNet they go back to the command station, the PR3, and give the feedback into train controller. So all these components know what they're doing and they kind of in unison. Then of course we need to add this block detection system. So if I close this window down and then open the latest one as far as I've got it to develop, and here we can see that I put in a few blocks, and there happens to be a warship sat in this lane over here, and the Pullman is sat over there. As you may be able to see this, the Pullman is actually a Pullman photo. It's a picture I've taken of my own, Pullman, the warship. It's a picture of my own warship, and you can import them into Train Controller. Now if I can simply drag and drop this loco with its coaches and drop it into this siding over this track over here, and it should stop abreast of the Pullman. So if I just zoom this right out a moment, right around here is that warship, and what I wanted to do is to trundle around the layout, cross the viaduct, straight over here, and then pull up next to the Pullman. And I would like it to stop alongside it. So what I can do a drag and drop on Train Controller. Sorry to make you dizzy with this camera zinging around. And then the warship should, like I say, make its way right around the layout. So if I put the camera onto the warship, and then I go to the computer and hit the drag and drop, and then we'll see where she stops. And I think she'll stop just short of the Pullman. And off she goes. Perfect. Now looking back into Train Controller, we'll see what happened with that sequence. I shall reset the warship back to where it was. So the warship's back in the siding, but this time I've turned that point against it. So before this can depart, that point has to change, and the route will be portrayed in yellow. And then when the loco enters this block here to show it's occupied, it should turn pink. And again, as it comes through, it'll go back to green. It'll make its way through here and then into this siding here. This one won't go pink. I don't believe I've wired that one in yet. And then should pull up alongside the Pullman once more. So if I go auto train drag and drop, take the warship, drop it down to here, the point changes, the speed comes up to 40, the loco leaves, enters this block, goes pink, leaves that block, and then makes its way back around to come alongside the Pullman. Beautiful. So perhaps the next question ought to be, how does the warship know where it has to stop? Well, if we go into this block, go into Edit, go into this block, and the block has two sensors. There's one there and one here. And in this block here, I've told it to go along 10 inches and then start braking to a crawl speed in 35 inches. And then when it goes from this block to that block, to stop. So what does that look like in reality? Well, here you can see the warship's where she stopped. And she comes down here at a crawl speed, but here there's a cut in the rail. And that's where one sensor changes to another and the warship receives its stop command, because as soon as a set of wheels that draw current cross into here, it's told to stop. Obviously it doesn't stop instantly because it has a rundown period, being a prototypical type locomotive, so it will always go down to a stop. So that's how the guts of it works. That isn't to say that I haven't made mistakes, because I clearly have, and in some instances I haven't used a cut. I've actually used a insulated rail joiner, and I've put the insulated rail joiner too close to the point. And if that happens, obviously, then this warship and this Pullman can get a little bit too close for comfort. But to get this locomotive to stop in exactly the right place, it needs to have its speed profiled. And to that end, you need to check it out and make sure that the CVs are all at certain levels. Looking just back at this Pullman track now, and you may be able to see that just here there's an insulated rail joiner which segregates this detector from this detector within the Pullman's block. Now it could be said that the way that this warship slows down as it pulls into this block is a bit sudden, because now it brakes quite severely. So what I shall do is just adjust the ramp speed, which is 10 inches, so that it doesn't move 10 inches down here before it starts to slow down. It will slow down immediately and make more of a gradual slowdown. So let's see what she looks like now with that adjustment. Much more realistic, just the job. But block detection also brings safety features. So I've put this 21-ton guards van on the normal track which the warship goes to, but because she has lights, she must draw current, and therefore train controller will know that we've had a breakaway of a freight train and will have that as an occupied track. So what will happen this time to the warship? So she pulls up short. And if I take away the guards van, train controller must now realise that the track is free and will retask the warship to come down and stop in its normal position. I thought it might be worth a quick look at one of these BDR 168s, which I'm sure is similar to the DigiKeys equivalent. And this one is split into 4 areas, and there's areas A, B, C and D, and there are 4 blocks in each of these 4, giving a total of 16. Now, to connect this to the layout, sadly Digitrax have made this blue connector, and you need to wire it in yourself, and as you can see from the wiring, it can be a little bit unusual. However, I'll show you in a moment the alternative. These are the 2 ports for LocoNet. There's one in and one out, so it loops along your layout, and there are 2 switches used for programming. On these contacts, Digitrax do supply a small plug with 4 LEDs, and this fits onto there, and then you can see that it'll light up when it's powered and which of the 4 blocks is occupied. As I've got numerous ones of these BDR 168s, I have numerous of these so small test modules. So here's one of the BDR 168s in situ. It's labelled BDR 168 number 62. No, I haven't got 62 of them installed. It's on board 6 and it's number 2. And here's the affair that's supplied from Digitrax, but I've opted to use these breakout boards from Aculights.com, and they are just the job, really. Makes it, rather than soldering these wretched connectors. I now use a printer for cable IDs, and I'm very grateful to a subscriber for putting me onto that, Martin Law, and there is a link in the Show More tabs to the printer. Now, looking at these LEDs, the single light in the centre just shows that track power is applied, and the bottom 2 lights here are for the Pullman, and the one above it is the Warship. Now, if I move the Warship into that last block, you can see that final light illuminates, and if I just by hand move the Warship off, so there is no detection, and both lights should extinguish. And that's the guts of it, really. The signal comes into this board, and it goes out on the LocoNet cables, which you can see looped in and out underneath, and then goes back to the command station, into the PR3 and back to the computer. So you've got the occupancy information going back to the computer, and that's really the guts of how it works. Well, as I'm sure you can see, there's a great deal to block detection and computer control, but it's one of the extremes. And here's a short sequence now from my very first video where I installed block detection and automation on my first layout Chadwick TMD. And there'll be a link to that in the closing sequence. So where does that leave you? Well, you can see there are simple DC alternatives. There's also in the DCC world something worth looking into, which is called asymmetric braking, and that's a way of sorting out shuttles without going into full computer control, but let's save that one for another day. So if you're thinking of going down this avenue, do your research and buy with care. It's an extremely expensive and addictive thing to get into, because once you start getting all finicky with your train movements, a whole new world appears, and there's some great forums on the internet to get involved with for advice and to see how other people are doing theirs. So in summary of the block detection side, that automation, it's either really DigiKeys or Digitrax. Those are the 2 main players, but do look into DigiKeys. It's something I'm not really au fait with. Like I said, I've knelt at the altar of Digitrax. I've got too much money involved to change. And the 2 programs that are worth considering are Train Controller through its bronze, silver and gold guises. We are talking a lot of money. And iTrain, which is the new kid on the block, which is relatively cheap when you compare it to Train Controller Gold. So there we are. I hope you found that interesting. I've got a great deal of work to do now on Chadwick to bring up the rest of those blocks to make it run. And in the meantime, I'd like to thank my patrons for their help, because without your help and the people who donate, I really couldn't put this channel together. So thank you very much. And if you'd like to become one, there's a link there. There's a link to subscribe just here, and subscribing is free. Anyway, there should be a video here and my very first video there. So take care, and I'll see you in a couple of weeks. Thanks for watching. Take care. Bye-bye.